Hello and welcome to Bite My Pie. There are lots of reasons why you may need to give a device on your home network a static or non-changing IP address. To set it up as a server, to apply some sort of web filtering, or simply so that you can connect to it easily, to name just a few. In this video we'll look at how to create a static IP on a range of devices from your router to a desktop PC or laptop and even a smartphone. So if this sounds useful to you, stick around. Before we get started, let's quickly cover some networking basics. On a home network, your router will typically take care of issuing IP addresses to the devices connected to it. This is a process known as DHCP or Dynamic Host Configuration Protocol. To help visualize this, let's imagine this roulette wheel is our router and we've just connected a laptop to it. It doesn't matter if this is over Wi-Fi or if you've plugged in a cable, the process is the same. The router dishes out an IP address, in this case 192.168.0.30. Most of the time this is great as it handles the process automatically in the background, meaning that you don't have to do anything. The problem is that this IP address can change. Let's say at a later date we reconnect the same laptop to our home network again. The router does its job and issues an IP address. You may get the same address, but then again it could be different. As on the screen this time it's 192.168.0.7. While usually this isn't a problem, and it should be fine for something like a laptop, it could be a major issue if the device in question is a home server or network attached storage box, as one minute it may be working and the next it's inaccessible. Not good news if you suddenly can't access your files on a shared network drive. By setting a static IP address we can stop this problem arising in the first place. The other thing we need to be aware of before diving in is the IP address range. As the name implies, this is the range of IP addresses that can be utilised on a network. On a home network this is usually something like 192.168.0.1 to 192.168.0.254. The third segment, or octet as each of the four parts is actually called, may vary. So you could also have something like 192.168.2.1 to 192.168.2.254 for example. This is what's known as a Class C network as it contains 256 IP addresses. So technically the last octet starts at 0 and ends at 255, but as these addresses aren't usable we'll omit them. Without getting bogged down in the details, IP addresses that start with 192.168 are one of a few IP ranges reserved for private use. This makes them ideal for home networks as they're designed for local use only and aren't routable over the internet. On a home network, the router will often use the first available IP address in its given range, for example 192.168.0.1. Then you have what's known as the DHCP scope or pool. Let's use another analogy to help us visualize this concept. If you imagine the pool table representing your home network and the triangle being your router, the pool balls show the DHCP pool, or the available IP addresses ready to be handed out to connecting devices. Although the pool table scenario only allows for 15 balls or IP addresses, as we previously discussed, on a typical home network this would normally be 254 usable addresses, for example 192.168.0.2 to 192.168.0.254. If you're thinking, hang on a minute, that's only 253, remember that your router will already be using one of those IP addresses, in this case 192.168.0.1. So when a device, e.g. a smartphone, connects to the network, an IP address will be issued. Here we see 192.168.0.2, the yellow ball being handed out from the available pool. If another device then connects, say a laptop, the router distributes a different IP address. This time we can see the red stripe or 192.168.0.3 being handed out. Note, at any one time each device must have its own unique IP address. As mentioned earlier though, this address will not necessarily always be the same one. Obviously this is where static IP addresses come in, where we assign a static, non-changing address to a specific device. Right, time to put the theory into practice. We'll start then with configuring static IP addresses on a router. Since you can't attach a monitor to your router, we need to connect to it from another device. So here I am on a Windows computer, and the first thing we need to do is find out the IP address of the router in order to connect to it. So to do this, let's open a command prompt by typing cmd and pressing enter in the search box. In here I'm going to type ipconfig and press enter. And if you look at where it says default gateway, this is the IP address of the router. So in my case it's 192.168.0.1. So make a note of it because you're going to need it in a second. Okay, let's close the command prompt. And now we're going to open a web browser. Enter the IP address of your router in the address bar. So mine is 192.168.0.1 and press enter. Now this particular router only requires a password to log in. On some models you might need to enter a username and a password. If you're not sure what the login credentials are, you can usually find them on the back of the router itself. So pop them in now and then click login. The first thing we want to look for is the DHCP server. Unfortunately, the location of this varies from router to router, so you might have to poke around a bit until you find it. I happen to know on this model that it's under administration. If I scroll down beneath LAN parameters, you can see here that this is where the IP address of the router itself is set. You'll probably just want to leave this alone. The subnet mask is 255.255.255.0, which is what you'd expect to see on a home network. To explain what's going on here, if we convert this 32-bit mask from its dotted decimal format into binary, we get the following. Just as when you mask a layer in Photoshop you can make changes to part of the image, a subnet mask does the same thing to an IP address, thereby letting us fix part of it while allowing the remainder to be changeable. As the first 3 bytes consist of all ones, this means that the first 3 octets of the IP address are fixed, but with the last byte being all zeros, this allows us to change the 4th and final octet of the IP address. And since a computer byte or 8 bits can have 256 different values, this is what gives our home network an IP address range from 0 to 255. If all that mathematical jargon sounded like a foreign language, don't worry about it. Just remember that if you ever need to manually enter the subnet mask for your home network, it's going to be 255.255.255.0. As you can see, the DHCP server is enabled. This is how we want it to automatically hand out those IP addresses to connecting clients. Next we have the DHCP scope or pool. This is currently set to start at 100 and end at 200. I'm going to change this to start at 50 and end at 100. This will allow for up to 51 devices to automatically connect to my network. Make sure that your range is large enough for the amount of devices you want to connect. The reason I don't want to set the DHCP pool to use the entire range of available IP addresses, which in this case would be 2 to 254, is that when you manually set a device itself with a static IP address, it's advisable to put this outside of the DHCP scope. Otherwise you may end up with conflicting IPs, which is when one or more devices has the same IP address. Something best avoided. Okay, next we have the DNS server. You can think of DNS or domain name system as being like a telephone directory for the internet. When you type in a web address, say bbc.co.uk for example, DNS servers are what direct you to the right place. If you're happy for your ISP or internet service provider to take care of your DNS queries, you can leave your router's IP address in this box. But if you'd sooner have someone other than your ISP do it, you can enter their IP address instead. A couple of popular ones are Google, which is 8.8.8.8, and Cloudflare, which uses 1.1.1.1. You could even have one in each, so we could put 8.8.8.8 in there for Google, and then we could put 1.1.1.1 in there for Cloudflare. So in the unlikely event that Google's DNS servers went down, it would use Cloudflare's instead. Note, by doing this on your router, all of the devices connected to it on your home network will use these settings. And when you're happy with your entries, click OK or Save or whatever the button is to apply the changes on your router. Right, after all that, it's time to set a static IP. Now, by doing this on your router, it's technically what's known as reserving an IP address, but to all intents and purposes it's the same thing as setting a static IP on the device itself. The only true static IP address on a home router is that of the router itself. The main difference, other than the fact that on a home network a reserved IP is typically set on the router and a static address is set on the actual device, is that a reserved IP address is usually within the DHCP pool, whereas, as I mentioned earlier, a static one is normally set outside of this. But these rules are certainly not hard and fast by any means, and different routers can vary in how they handle the process. If you're not sure about your model, a quick Google search may help. The main advantage of using the router to assign all of the IP addresses on your network is that they can then be managed centrally from the router itself. Another advantage of doing this is that you can simply leave all of your devices to receive their IP addresses automatically. But there are times when a static IP address on the actual device may be the best way to go, which is why we'll be covering both methods in this video. Now, to reserve an IP address for a device on your network, you need to find the relevant section of your router that enables you to do this. Again, on this router, I know that it's in the Advanced section. You can see how interchangeably the terms are used, as on this model it's actually referring to it as a static IP rather than a reserved IP address. With some routers, it's as simple as selecting a device from a list of those connected to it and confirming the IP address that you want that device to use. Unfortunately, with this model the process is a little bit more involved, but it's still not difficult. So what we need to do here is find out the MAC address of the device that we want to set the static or reserved IP on, as the router will use this to confirm that that device always gets the same IP address. You can think of the MAC address as being like a label or tag that's associated to the network adapter in a device. So if I minimize the web browser, since I'm already connected to the router from this Windows computer, I might as well reserve the IP address on this one. To do that, I'm going to open a command prompt again, and this time I'm going to type ipconfig like we did before, but I'm going to add a space /all onto the end of it and press enter. As you can see, this gives us more information than the last time. The computer is currently being given an IP address of 192.168.0.50. We can now see the physical address, or MAC address as it's also known, of the network adapter. So jot that down as we'll need it in a moment. There's only one network card listed here, but if your computer has more than one, for example a wireless and wired adapter, make sure you get the one that's connected to your router. Okay, let's close the command prompt and reopen the router page. So since my DHCP pool is now between 50 to 100, I need to reserve an IP address within this range. Now, if you remember, the Windows computer was already using 192.168.0.50. Now I could stick with that, but to make sure this process is actually working, I'm going to change it to something else. So I'm going to go with 192.168.0.75. Next, I need to enter the MAC address I made a note of earlier. So that's 001B44113AB7. And then I can enter a remark which will help me identify the device. So I'm just going to put Windows PC in there. And now I can click on the plus button. Now if you get that message about entering a valid MAC address, obviously double check your digits, but if they're correct, as mine are, you may need to enter it in the full MAC address format. All that entails is putting a colon between every two digits, so work your way along the line and enter your colons. And when you've done that, try entering it again. Great, that's added it, so now I'm just going to click on OK. Obviously you can give multiple devices a reserved or static IP, but for this demonstration of how to do it on a router, that will do. So let's log out of there and close the browser. Right, the moment of truth. Let's see if it's worked. So we're going to open a command prompt again and enter ipconfig, and that's exactly what I wanted to see. The IP address is now on 192.168.0.75, and as long as I keep that reserved static IP entry on the router, this computer will always have that address. If you're not seeing the IP address that you set, you can either restart your computer and try again, or you can enter the following two commands. The first one is ipconfig /release. As the name suggests, that lets go of the network adapter's current configuration. And then the second one is ipconfig /renew, and press enter again. And that simply pulls the settings back into the network adapter from the router. And hopefully, even if you didn't before, you've now got the IP address you were expecting. So let's close out of the command prompt to finish. Now, while I just used the router to reserve an IP address for a Windows computer, you could do this for any device on your home network. Okay, so rather than using the router, let's now look at how we manually set up a static IP address on a Windows computer itself. Here we are on the Windows 10 desktop. This could be a laptop or a desktop PC. First we need to click on the Start menu and then select Settings. Let's maximize that window. From here we're going to go to Network and Internet, and then we're going to click on Change Connection Properties. Under IP Settings you want to click on Edit, and then from the drop down list we just select Manual. And as our home network is an IPv4 network, we want to turn that on. Right, starting at the top, we need to enter an IP address. Remember, this needs to be outside of the range of the DHCP scope or pool. If you recall, on my router I set this between 50 to 100, so I'm going to use 150 here. That means the full address will be 192.168.0.150. Next we need to enter the subnet prefix length, so this is 24. If, like me, you like to know why you're entering a particular value rather than doing it simply because someone said so. As mentioned earlier when we discussed the subnet mask, on a Class C home network the first 3 octets are fixed, and since each octet is 1 byte, 3 bytes equals 24 bits, hence the 24. Anyway, before we all burst with excitement, let's get the rest of this filled out. So the gateway is simply the IP address of your router, so in my case that's 192.168.0.1. Next we have the DNS. I'm going to use Google's public DNS 8.8.8.8 address as the preferred, and Cloudflare's 1.1.1.1 address as the alternative. If we scroll down, you can leave IPv6 turned off and then click on Save. So if you look across here under IP settings, you can see that our changes have taken effect. And if we close this window, we can double check by opening a command prompt. So type cmd in search and then launch the command prompt. From here we just need to type ipconfig, all one word, space / all and press enter. And you can see down here under Ethernet adapter, yours might be under Wi-Fi adapter if you're connecting over wireless, we've got our change settings. So here's the static IP address I set, 192.168.0.150. We set the subnet mask in its length form of 24, which is the same as its dotted decimal notation of 255.255.255.0. We've got the default gateway of the router's IP address of 192.168.0.1, and then the 2 DNS servers that are set, Google's and Cloudflare's. So hopefully all of the settings you chose are present and correct, and then we can close the window. And that's how you can manually set an IP address in Microsoft Windows. Okay, now let's look at how to set a static IP address on an Android device. Here we are on the home screen. This is just a cheap and cheerful Alcatel smartphone. So the layout may be slightly different from yours, but the procedure is basically the same. First we need to open the app drawer. On this model we can tap the icon in the dock. Quite often on Android you get to it by sliding up from the bottom of the screen. From here we're going to tap on Settings. Then you need to find the section with your wireless networks and go into the Wi-Fi so that you can actually see them. Next, hold down on the name of your Wi-Fi network, in my case Bite My Pie, until the pop-up window appears. And from here we're going to modify the network. You can see at the moment that the router has automatically given this device the IP address 192.168.0.51. You need to swipe the screen to scroll down to the bottom where it says Advanced Options, and then select that. I'll press the back button to get the keyboard out of the way. Next we need to tap on DHCP and then select Static. If your screen's small like on this device, you may need to scroll down to see the bottom of the display. If you've been watching the video since the beginning, even though we're on Android, hopefully these settings are starting to look familiar to you. So let's first tap on the IPv4 address and enter the static one that we want. I'm going to go with 192.168.0.200. Then select the gateway. As is the case here, it may have pre-populated this for you, so just check that it's correct. Remember, this is the IP address of your router. Scrolling down, we then have the network prefix length. As mentioned earlier, on a home class C network, if it's not already, this should be set to 24. And then lastly, we have the DNS. In my case, this has been pre-populated with Google's public DNS IP addresses. Let's say on this occasion I don't want to use those. So in DNS1, I'm going to remove that and enter the IP address of my router. Good old Google doesn't want to let go, so if this happens on yours, just tap at the end of the line and then delete all the 8. And then in DNS2, if you're going to use your router, or in other words your ISP, for your DNS queries, if it lets you leave this blank, then do so. But if it's going to pre-populate it with another IP address, as is the case here, just type in the IP address of your router again. And when you've done that, you can tap save. And that's it. If you now tap on the name of your wireless network, you should see that your Android device, be it a smartphone or tablet, is now using the static IP address that you set, in my case 192.168.0.200. And if you recall, as discussed earlier, importantly, this IP address is outside of the range of my DHCP pool. And simple as that, that's how you set a static IP address in Android. In case you wanted to reserve an IP address instead, let's quickly look at where you find the Wi-Fi adapter's MAC address in Android. So if we go back into settings, this may vary from device to device, but generally you want to find the section where it says About Phone. And then in here it may be listed as something like hardware info. On this device it's in status. And then down near the bottom we have the Wi-Fi MAC address. If you want to set a static IP on an iPhone or iPad, again you need to head into settings. From here you want to tap on Wi-Fi and then select the little I button next to the name of your Wi-Fi. From there, if you have an older version of iOS, you can tap on static, or for more recent offerings you need to head to Configure IP, then Manual. To find the MAC address in iOS, return to Settings and this time tap on General. Next select About and you'll find the MAC address listed as Wi-Fi address. Before we finish, I'd like to briefly go over a couple more points. Obviously, if you ever want to revert a device back to receiving an automatically assigned IP address from the router, simply return to the device's settings and change it back to DHCP. Also, if you start setting static IPs on your devices rather than issuing reserved IPs through your router, it's a good idea to keep a note of them somewhere so you don't accidentally assign the same one twice. Fret not though if you ever find yourself wondering what on earth's going on your home network. There's a particular type of software that can help. Known as a network scanner, some of these are even freely available. The Fing Network Tools or Fing Network Scanner apps can be installed on your Android or iOS devices respectively. Links to these are in the video description. Using such tools you can easily scan your home network to get a list of all of the connected devices along with their IP addresses. Fing also detects a device's MAC address, which can be very handy. If you don't see it on the main screen, tap the little arrow for more details. And that brings us to the end of this video. There's been a lot more theory in this one than usual, and if you've made it this far, give yourself a huge pat on the back. I hope that you now have a better understanding of how IP addressing typically operates on your home network and how to better take control of it. Being able to assign static or reserved IP addresses will help with some of the future up and coming projects on the channel. We've been looking at what's known as IPv4 or Internet Protocol version 4 networking, which are 32-bit addresses. If you really want to make your head spin, look up IPv6. As always, if you enjoyed this video, please like and subscribe, and if you'd like to be notified when I post the next one, just click the bell icon. Thanks for watching, and until next time, take care.